2.2, we're going to take a look at graphs of relations and functions. And we are going to have there's really 7, yeah. There's really 7 basic graphs we're going to take a look at. These come up frequently. So we see them, in different places. We'll see them again later on when we talk about shifting and changing our graphs around. But here's our first location where we're going to see them. So many of these graphs are going to be looking like things that you've seen many times before. The first one is the graph of y equal x squared. As you're working with these basic graphs, when we're working with lines, we really just need 2 points to graph a line, right? Because we connect them, it's straight through, it's easy. When we're working with basic graphs like this, we need at least 3, but oftentimes 5 is necessary to get a real good idea of what the graph is. So what I'd like for us to do each time is to select values that are sort of convenient to use. And they repeat a lot in what they are. So as we look at these convenient values, you'll see me using a lot of values that are the same. Sorry. There's x and y. So my equation is y equals x squared. And I'm going to use -2, -1, 0, 1, and 2 as my basic points. And we'll repeat those on many of the graphs. There's a couple places where we won't, and I'll talk about why that happens. But we're taking each of those values and we're substituting it in to this x squared equation. So if I take -2 and I square it, what is -2 squared? 4. What is -1 squared? 1. What is 0 squared? 0. 1 squared? 1, and 2 squared? 4. Okay, so is everybody good with where those values all came from? Okay, the left-hand values I just gave you as their convenient values. The right-hand values we found based on that. And we're going to plot those on the graph. So I have -2, 4. So that's going to be right here. I have -1, 1 would be here. 0, 0 is my origin. And then I have 1, 1 here. And 2, 4 would be up here. And if we connect these appropriately, we could put more points in if we wanted to converse about that. It connects in a U-shaped pattern. And does anybody remember what the graph of this is called, the general shape? It's a parabola. Yeah, parabola. Good job. So as we look at each of our graphs, we're going to be answering the same set of questions every single time. What is the domain? What is the range? Is it increasing, decreasing, or constant? And if it does more than one thing, you have to show where. So we'll start with the domain and range. We talked a little bit about domain and range last time. So a lot of what I'm going to be doing today is going to feel like, wait a minute, didn't we discuss that? And the answer is, yeah, we did. So it showed up for the first time for us in section 2.1. Okay, so if you'll remember, your domain are your x values. And as I'm thinking about a graph, what I want to be able to do is move from the far left to the far right walking along the graph. So I'm walking along the x-axis and I'm looking up and down. On this one, I really only have to look up because there isn't anything below the x-axis. But everywhere I see a value as I'm walking is part of my domain. And on this one, that's everything, right? From where I start on the far left to wherever I go on the far right, I always have part of my graph showing. There's no jumps, there's no gaps, none of that. So my domain is -infinity to infinity, because I can go to the far left and I go to the far right, and I always have graph values. On our range, remember we're climbing up the y-axis, right? So as I'm climbing up the y-axis, where is the first I don't have anything below the graph. Where is the first location where I see part of my graph? At 0. And I actually see it right at 0, meaning I'm going to use a bracket at 0. Actually, at 0, I have graph values. And as I continue to climb up, I never stop seeing values as I look to the left and the right, all the way up. Yeah? So this one continues on to infinity as well. Now, it's important for me to make note that the range is the only time that I talk about y values. Every other time, when I talk about the domain, here in a moment when I talk about increasing, decreasing, constant, I'm always referencing x values. Okay, so the range references y's, domain references x. And down here, all of these reference x values as well. That is often a point of confusion when we get to the increasing, decreasing constant. We're always referencing x values. Okay, so again, we're going to start on the far left of our graph, x values, and we're going to be walking towards the right. And initially, what is my graph doing? Is it increasing, decreasing, or constant? It is decreasing initially, from the far left until I get to what? 0, or the y-axis, right? Right until I get to the y-axis, my graph is going downhill from left to right. We're always going to read a graph from left to right. So this graph is decreasing as we move from negative infinity all the way until we get to 0. And there's different things that our textbook might do with this 0 at the end. I'm not terribly concerned about it. Most books, and I don't think this book is one of them, but most books that I've used simply always use parentheses for increasing and decreasing and constant values. And the reason that they do is because what are you doing at a specific point? Well, you're not doing anything. You're just stuck there. It doesn't make sense to say, what's happening at 0? Am I increasing or decreasing? Well, I'm not doing anything. I'm just standing there, right? Before 0, I'm decreasing. And after 0, I'm increasing. So what would we say happens at 0? Well, it doesn't really make a lot of sense to say things are happening at 0 because nothing actually happens at 0. It's only over an interval. So I use parentheses, but if you forget and you use brackets, it'll just be fine. We'll mark the parentheses, we'll move on, no points taken off, okay? Okay, so starting at 0 then, and as I move to the right-hand side after that, what's happening? It is increasing then. I'm going uphill at that point, again, moving from left to right. So this graph is increasing as I move from 0 to the right forever, infinity. And there's no place where it's constant. We're not going to have a lot of examples of constants today, but constant would mean that it's flat. And this graph doesn't have any places where it's flat, right? A 0 slope, horizontal line kind of piece. It doesn't have that. Okay, is this one okay for x squared? Okay, next graph. Okay, I don't know what I just did. There we go. That's not it either, is it? Am I missing a slide? It looks like I am. I don't have my slide for 2. Hang on. 2 and 3 are missing. Okay, let me just come to the back of it and I'll put it back here. But we don't want a white screen. That's really hard to see. We'll use pink. Okay. Sorry, I'll have to check and see where my slide went. Number 2. Do you want me to use white or do you want me to use black on this screen? Oh, I got both of your answers. That's not good. Let's change the color of the screen. How about this? Now we all want white. Okay, we'll use a chalkboard background. Y'all making it hard on me. Okay, number 2 was the equation y, well, get that y back, y equals square root of x. And we're doing the same thing. We're finding the domain, we're finding the range, we're graphing it, increasing, decreasing, all these details that we had on the slide that I was just on before, way back here, right? All these details are the same questions. We're going to work on each of them. So over here, we're going to start with, I'll write down those pieces. I want domain, I want range, and then I want increasing, decreasing, constant, and I want a graph. So I'm going to make a number line, or not a number line, like a T-chart of values. I want x values and I want y values, but I don't really want those same x values because negatives have a problem, right? What if I put a negative 2 into this? I get i's, and I'm working with graphs that are real number graphs, right? So I don't need the negative values, but starting at 0 is plenty sufficient. I can start with 0. And really 0, 1, and 2 is enough. If you wanted to do another value, you could. To be honest, 0, 1, and 4 is a little bit easier. So maybe you want to choose 0, 1, and 4. I think I will. The reason is because I square root them very nicely, right? What's 0 squared? The square root of 0. It's 0. What's the square root of 1? And the square root of 4? 2. And if you wanted to do 9, that would be another next one that you would want to do, maybe the square root of 9, and so forth. This is really probably enough for our purposes right here, so I'll stop at that point. I'm going to put my graph down here. I'm plotting the point at 0, 0. So that's right here. And then 1, 1, which would be right here. And then 4 and 2, which should be right here. Okay? So those are my 3 points. This graph actually looks like this. And what it really is it's sort of a half of a parabola that's on its side. So if you can imagine taking our parabola, flipping it on the side, and then forgetting the bottom half of it, that's what we have. Okay? So this is my image that I'm working with, that I'm going to be talking about domain, range, and increasing, decreasing constant. So what is my domain for this graph? If I start on the far left and I move to the right, where do I first start seeing values? At 0. And it's a bracket at 0 because it actually equals 0 there. Okay? Where do I stop seeing values? I don't, so it's infinity, right? If I'm climbing up the y-axis, where do I start seeing values? At 0. And where do I stop? Negative infinity. It's really slow, right? I mean, this is not going uphill very fast, but it continues to go uphill forever. Right? I can do square root of 100, I can do square root of 1,000, I can do square root of 10,492, whatever I want. It's always going to be a bigger value than it was before, so it's still infinity even though it's slow. Yes, Elizabeth?
So for the domain, when would you not, like, what would it look like if you didn't have a bracket?
You'd have an open circle or you'd have an asymptote. And I think we have an example of one. Yeah, we have an example of one later. I'll show you when it happens. But it would have an open circle here, right? Which means you can't equal that value. Or you'd have something where there's an asymptote showing up. We don't have any of those to show you today, but that was another possibility. I don't think so. I don't think there's any graphs with that in there. Increasing, decreasing constant. So again, we flip back to talking about x values and moving along the x-axis. So I'm moving along the x-axis. I see my values starting at 0. What happens when I'm starting at 0? Am I increasing, decreasing, or constant? It's increasing. So as I move along the x-axis, my graph is going uphill. So this is an increasing graph. And it's increasing everywhere. So it's increasing from 0 to infinity. If you want to put a parenthesis on the 0, you can, kind of based on what I've talked about before. Because it doesn't do anything before that, if you put a bracket, it kind of makes sense here to talk about it in a bracket. But either way is fine. I'll stick with my parentheses every time I talk about increasing, decreasing, constant. And this part, I didn't write it, is the increasing. And on this particular one, that is the only thing that's happening on this graph, right? I don't have multiple things happening. It's simply always increasing. Okay, and the other one that is left out of the notes for whatever reason is number 3. So number 3 actually looks a little funny. It says x equals y squared. We're still going to talk about the domain, the range, and whether it's increasing, decreasing, or constant. Really close. Okay, so did you guys hear Noah's question? He wants to know if this is the same thing as y equals the square root of x.
Y equals plus or minus the square root of x?
Yeah, it is y equals plus or minus the square root of x. Visually speaking, and we'll show it here in a second as we get our points, what we're going to have is we're going to have this sideways parabola with both halves, the top half and the bottom half. That's what we're going to draw here in a minute. So very good observation. When it's written this way, though, before we changed it to our observation piece over here, it's not very easy to give x values and to figure out what the y values are. So as I'm trying to isolate these and figure out what my x and my y chart might look like, it'll be far easier for us to actually choose y values and to figure out what x would be. So I'm going to choose those same y values, -2, -1, 0, 1, and 2, that I had when I was working back on the previous one on problem number 1. So if y is -2, -2 squared would then give me 4. So x would be 4. Okay, sorry, because I changed that. If y is -1, the negative 1 squared would give me 1. If y is 0, 0 squared is 0. If y is 1, 1 squared is 1. And if y is 2, 2 squared is 4. So these are the points that I would plot. So down here, I have points. The first point is at 4, negative 2, so that's actually down here. And then I have 1, negative 1 would be here. I have 0, 0 is here. 1, 1 would be right there. And then 4, 2 would be right there. And my scale isn't perfect, but I hope that you can get the sense that, in fact, I have that same top half that I had over here, right? But I also have the corresponding lower half now from that equation. Is it a function? Nope, it's not. It fails the vertical line test, so we haven't identified that on all of our problems, but we could certainly be asked that question. This one is not a function. Was the one before, the one that's on the screen, number 2, was it a function? Yeah, it is. So this one is a function. Sometimes they ask you these questions on these problems too. So we need to do domain, range, and increasing, decreasing constant. Let me give myself a bit more space since I'm cramming things in here. Domain. If I start from the far left and I go to the far right, it's not a function, but what's my domain for what I have? Still 0 to infinity. I just happen to see values above and below simultaneously. That's okay. It's still got a domain. The domain is 0 to infinity. The range is a little bit different though. As I'm climbing up the y-axis, what's my range going to be? Yeah, negative infinity to positive infinity, because I have sort of the bottom half of that parabola. And how about increasing, decreasing constant? Well, this one's tricky. I can't actually even answer this question because it isn't a function. It doesn't even make sense to ask. So I don't throw that in there to be like, beware, they're going to ask you this question. They just wouldn't ask you that for this question. Does that make sense? Because it doesn't make sense. If you think about it, if I'm talking about x values, right, well, it's both increasing and it's decreasing on different pieces at the same time. And I don't have a way to describe that with the way that we've got our conventions of our intervals. Okay, let me go back real quick to number 1 just because I didn't write it down. But is number 1 a function? Yeah, number 1 is a function.
So it's not a function if it fails the vertical line test?
You got it. Not a function if it fails the vertical line test. This one was. All right, let's move on to number 4. We're going to do that same XY chart. Unless there's good reason not to, we tend to use the negative 2, negative 1, 0, 1, and 2. And in most cases, that works well for us. Negative 2, negative 1, 0, 1, and 2. So on this one, if I have negative 2 cubed, what's negative 2 cubed? Close. Negative 8. Yeah, good job. What's negative 1 cubed? Negative 1. 0 cubed. 1 cubed. And 2 cubed. 8. So these would be my pairs that I would plot. So I have negative 2. Negative 8. So that one would be down here. Negative 1, and 0, 0. So they look like this. And then I have 1, 1. And then I have 2, 8. So something like that. We're going to be doing a lot of graphing in this section, obviously. If you want to use graph paper, you certainly can. You don't have to. If you want to print off graph paper from online, like just grid paper, if it's helpful to you, you could do that too as an option as you're thinking about your homework. So we're going to connect these now, and these actually connect like this. And that's roughly speaking what an x cubed graph would look like. So now, domain, range, increasing, decreasing, constant. So what is my domain for this function? Yeah, so remember domain, we're moving along the x-axis. We have graph values from the far left all the way to the far right. So my domain, actually let me shift this up just a slight bit. My domain is negative infinity to infinity. How about my range if I'm climbing up my y-axis? Same thing. Negative infinity to infinity. Is this a function? Yeah, this one's a function, which means I can talk about the x pieces just fine. I have a function here. So how about increasing, decreasing, constant? So again, remember, we're going back to x values. I'm moving along the x-axis. From the far left, where at the x values start, what initially is happening to my x values? They're increasing, and how long do they increase? The whole time, actually. So they do sort of have a different patterning, right? It's not as steep at 0, but it's still going uphill at 0. So here my increasing is happening from negative infinity to infinity, which means that these don't happen. It's not decreasing. It's not constant anywhere. So they're not applicable in A. Or you could say none if it were phrased like that. Okay, cube root of x. Okay, so when we saw x squared, it looked like this, and when we did the square root of x, we flipped it over and we dropped a piece of our branches, right? If we did the plus or minus, we kept the piece. We don't have to worry about pluses or minuses here, but this is my x cubed. In a very real sense, my x cubed is also going to flop to the side. It's going to look a little bit different than that, but that's the basic idea. So as we look at our xy values here on this one, this aren't going to have the standard negative 1, 0, 1, 2, so forth. Because it's easier, actually, to choose values that are nice to choose, right? So here, my x value, my y value. I don't really want to choose something that's not a perfect cube. I'd like to choose some perfect cubes. And the perfect cubes that sort of came about over here are some really nice ones to choose. So I'm actually going to look like I'm just switching my x and my y values almost, because it's really nice to do a cube root of negative 8. What's the cube root of negative 8? Yeah, negative 2. What's the cube root of negative 1? Negative 1. What's the cube root of 0? 0. I'm just picking convenient values, and because I just did the previous line, the previous problem, I actually know what those convenient values are right off the top of my head. The cube root of 1 is 1, and the cube root of 8 would be 2. So I'm going to plot these points on my graph. I think that was there. Okay. Yeah, that's enough of them. And then I had 2's. That's okay, I think. All right, so I have negative 8, negative 2. That's right here. I have negative 1, negative 1, 0, 0, 1, 1, and 8, 2. So if I were to connect these dots, it looks something like this. And can you see how, in fact, it looks like it's been flopped over? Not exactly a flop, because it looks like it's been flopped and then it's like twisted again, but it does look like it's on its side. It's a cube graph on its side. What's the domain? It's negative infinity to infinity. What's the range? Negative infinity to infinity. If I start on the far left, remember x values, and I'm moving to the far right, what is the graph doing initially? Increasing, decreasing, or constant? Increasing. And how long does it increase? Negative infinity to infinity the whole time. And I didn't actually say it, but is the graph a function? Yeah, it's a function. That's what allowed me to do the increasing, decreasing, constant. And of course, there's no decreasing, there's no constant, so those are not applicable, or they're just none. Okay, 2 more left, 6 and 7. Number 6 actually looks kind of scary, and I don't want to go through a whole lot of detail about what this, what the points situation is, because once I manipulate the equation just a little bit, you're going to recognize what happens. So what I'd like to do is manipulate the equation so you can see that this is a function you know. If I were to square both sides, I would get y squared on the left, And the plus or minus would be eliminated because I'm squaring, and I'd get r squared minus x squared. And if I added my x squared to both sides, I would end up with an equation that says x squared plus y squared equals r squared. What is that an equation of? That's an equation of a circle. Okay? So you guys know what a circle looks like. This is not, a new information piece. You know what a circle looks like. And the radius, however far out, tells you exactly how far your circle out, goes out to the left, right, up, and down. So as I'm looking at my circle to draw, I'm going to be drawing a circle with radius r. And while this is all true, I need some space, so I'm going to go ahead and cut this. And my circle needs to look something like this, and I'll shift it. Mostly all right. So my radius is showing up here and here, right? So this is at r, whatever it is. Over here, we're at negative r. On the top, we're at r, and on the bottom, we're at negative r. Is that okay? So it depends on what r is. If r is 5, if r is 1/3, it doesn't matter, but it's just going to determine how far out we go. All right, domain, moving from the left to the right. What's my domain? Where do I first start seeing x values? At negative r. And I have a bracket there because I see them right at negative r. And how far do I go before I stop seeing x values? R. What about the range? I'm climbing up. Same thing, right? Negative r to r. Is this a function? Nope, not a function, which is great because not a function means that I don't have to do these at all. They don't make sense. They wouldn't be asked is what it really means. They wouldn't be asked. The last example we have seen kind of pop up a couple of different times. We've seen absolute values with equations. You've also seen absolute values with inequalities now. And now we're looking sort of at a two-dimensional picture of absolute values. We can use that same set of XY ordered pairs that we were using before. They work very nicely. I can use -2, -1, 0, 1, and 2. So when I take the absolute value of -2, I get 2, absolute value of -1, 1, absolute value of 0, 0, absolute value of 1, and absolute value of 2. So these are my ordered pairs. We have -2, 2, -1, 1, and 0, 0. And then I have 1, 1, and 2, 2. And an absolute value graph actually looks like the V. Okay? So parabolas come from x squareds. They look like a U. And then absolute values form a V shape like this. That's my shape. Is it a function? Yes, it is a function. What's its domain? Yeah, it's -infinity to infinity, much like our parabola, right? What's its range? Yeah, 0 to infinity. Again, kind of like my parabola. This one actually does have pieces that change, though. Most of ours have had either have had a constant, not constant, have been increasing specifically and only increasing. But this one actually changes. So when I start on the far left, again, you're thinking x values, and as you're moving, what is initially happening to your graph? It is decreasing. So it starts decreasing at -infinity. And where does it stop decreasing?
0.
At 0. And again, I'll put a parenthesis. If your book uses a bracket, that's fine. How about increasing? Yep, it's increasing from 0 to infinity then, and it does not have any constant values, no flat pieces, no horizontal pieces. Okay, any questions on those? Okay, so we're going to do some other examples now for some graphing where they utilize some of these basic functions. They also utilize on number 8, for example, the equation of a line. So as you're working with these, you're welcome when you get to a line to graph it in whatever ways you know to graph lines. That's fine. It's probably very helpful if you want to do a line to only, well, I should say, if you have a line, you really only need to plot 2 points. So if you want to do an ordered pair, like we were doing on the previous ones, which works really nicely, you can. You just pick x and y values that solve the equation. For example, if x is 0, what's y? It's 0 on this equation. If x is 1, what's y? 1. And you could pick a variety of other values. It's nothing special about those ones. But my point would actually be at 0, 0, and at 1, 1. And because it's a line, and I know it's a line, right? Because it's got x to the power of 1, it's got y to the power of 1. I don't have any absolute values or radicals or anything else like that in there. So I would connect these, and there's, hang on. Sometimes catching the slope and the points at the same time is not straightforward when I'm working on the screen. We have this graph, basically. So what is the domain for this graph? Negative infinity to infinity. What's the range? Negative infinity to infinity, right? Climbing up the y-axis. How about increasing, decreasing, constant? So if I start on the far left and I'm moving to the far right, what's happening initially? It's increasing. So it starts increasing at negative infinity. How long does it increase? Until I get to positive infinity, yep. And on this one, it does not have any decreasing or constant pieces. Okay, number 9. On number 9, you see an absolute value, which means you better see a graph that has a V shape when we're done. Does that make sense? Okay, now we want to choose values that are nice values, and you can choose negative 1, 0, and 1, negative 2, negative 1, 0, 1, and 2 a lot of times, but sometimes it's easier to shift the values you choose just a little bit. So I put this one in here because I want to show you how you can shift those values when it becomes apparent that it might be nice to do so. So here's x and here's y. So a value that would be really nice inside with the 1 would actually be values that actually end up giving me that 0, 1, and 2 maybe on the outside that showed up. So for example, and they don't have to go in order, so I won't go in order. If I choose the value of 0, what's y going to be? It'll be negative 1. So on the inside, I'd have 0 plus 1, which is 1. The absolute value of 1 is 1, but then there's a negative on the outside. Is there another value on the inside that I could put in that would give me a value of 1 besides 0? What was it? Somebody said it. Negative 2. Negative 2 is another one, because what's negative 2 plus 1? Negative 1. And what's the absolute value of negative 1? 1. And then I've got my negative on the outside making it negative 1. So if you don't happen to see that and you use other values, it's okay. But there is sort of a symmetric patterning going on with a V shape. There is with a U shape as well, right? The parabola shape. So that's a nice one. So you're like, okay, great, that's 2 values. Well, maybe I want to know what's happening in between, right? So maybe I will pick a negative 1. What happens when I put negative 1 inside of this? Negative 1 plus 1 is 0. The absolute value of 0 is 0, and negative 0, or the opposite of 0, is still 0. Now, the reality is that's probably enough to graph it. If you want to pick a couple more, picking values on either side of the 0 and negative 2 would be nice ones to pick. So like negative 1 is actually a fairly nice value here. Or, sorry, not negative 1. Negative 3 is what I meant to say. Negative 3. Negative 3 plus 1 is negative 2. Absolute value is 2. And then the negative in front makes it a negative 2 again. And then if I pick a value bigger than 0, like the value 1, 1 plus 1 is 2. Absolute value is 2 with the negative in front would be a negative 2. Now, if all you plotted was the first 3, let's just plot those so we can show you what I was talking about by choosing those nice values. We had 0, negative 1, so that would be this point. We have 2, negative 1. Oh, I'm sorry, I didn't plot that right at all. Let me try again. I'm going to put some numbers on here. I have 0, negative 1, which should be down here. That's what I meant to plot. I have negative 2, negative 1, which would be here. And I have negative 1, 0, which is here. So even with just those 3 points, my scale's a little bit off, but even with just those 3 points, do you see the V? Do you see how it has to look? Yeah? If you didn't, then looking at the next points hopefully should do it for you. You have -3, -2, which would be here, and 1, -2, which would be here. So minimum of 3 points to plot if you know that the shape's already a V anyway to get it. So either way, you have roughly this graph. What's my domain? Negative infinity to infinity. What's my range? Ooh, good. This is the first one we've had like that. Negative infinity, it ends at 0. It equals 0 because I actually have a value that I'm at on the x-axis there. So negative infinity to 0. How about increasing, decreasing, constant? Let's start at the far left. What is it initially doing? It's actually increasing initially, right? So it's increasing from negative infinity to 0. And then at 0, or at, not 0, I'm sorry. 0 is not right. I said it, not you. It's at -2. Remember, we're reporting the x values. The x value where it stops increasing is at -2. Does that make sense to everyone? Okay, we're not looking at the y's, we're looking at x. So we're walking along the x-axis, and at -2, I stop increasing. And at -2, I start decreasing. Okay, so I'm not climbing the graphs, I'm walking along the x-axis. And as I walk along the x-axis until I get to -2, the graph itself is going uphill. And then after -2, the graph is going downhill. So -2 to infinity, it's going downhill. And it doesn't have any constants. I haven't actually said it along the way, but are 8 and 9 functions? Yes, they are. We weren't asked for that, but they are in fact functions. The last 3 that I have, 10, 11, last 4, 10, 11, 12, and 13, are all a little bit different. They're actually ones that I'm going to draw the picture for you in. Okay, so we're not going to find a table of values. We're just going to be looking at a graph that's already given to you. It's going to look a little funny. Sound good? Okay, so the graph that I'm starting with on this one looks something like this. So nobody's asking you to graph it, they're just giving you this graph. And they even will often tell you, so I will too, what these corners are. This corner is -2, 3, and this corner is 2, 3. Okay, is everybody good with that? Graph starts out given to you. I just don't have great capabilities with my technology of printing it into your notes. What's my domain? Negative infinity to infinity. How about my range? Negative infinity to 3. So my y value of 3 is where I've topped out, sort of like a plateau. So this is negative infinity to 3, and I do have a equaling 3 there. Okay, so again, as I start on the far left of the x-axis, I'm initially doing what? What is my graph initially doing? It's increasing. So from negative infinity to where? Where does it stop increasing? X value -2. What happens after -2? It's actually constant. So we finally get to see one of these constant ones. I told you we would have one. So down here, it's constant from -2 until when? Until 2. What happens from 2 and after? Now it's decreasing. So this one decreases from 2 to infinity afterwards. If I were asked, is it a function? Yeah, it's a function. It's funny looking. It's actually called a piecewise function, but it's a function. Here's number 11. The edges here are at -3, -1. Sorry, I need to shift my graph down a little bit. That's what happens when you look at your back graph wrong. Looks like that. The top is at 0, 2. And this point right here is at 3, -1. So I think I've got them all drawn in. So this is, again, this is where it starts. Nobody's making you graph it.
Is that -0?
Is that a negative?
-3.
No, it's a one.
Oh, it's a 1 in parentheses.
Oh.
Yeah, it's just sloppy. Let me shift it and then it'll look a little bit better. Thank you for asking. Yeah, -3, -1. Okay, domain, moving from the left to the right. Where do I see my domain values? Where does it start? -3, x value of -3, and it actually equals it. There is a closed circle. Do you see that? So use a bracket here for my closed circle. Where do I stop seeing x values? 3. How about my range as I'm climbing from the bottom up? -1 to 2. What is this a graph of? Looks like half of a circle, a semicircle, right? I mean, so that's what we're actually seeing here. Is it a function? Yeah, it is. Okay, good. So as I'm moving from left to right, what happens initially? Initially, it's increasing. So it's increasing starting at an x value of -3. And it increases until I have an x value of 0. So the part of the graph that's actually increasing is this part of the graph, right? And it's happening along this part of the x-axis. Okay, so my increasing is from -3 to 0. And again, I'm going to use parentheses on those. What happens from 0 as I continue to the end now? It's decreasing. So it's decreasing from 0 to 3, and it does not have any constant pieces. Okay, any questions on that one? Okay. The next one, I actually have an equation given, but it's given in a piecewise form. So I'm going to have time to finish 12. What I'm going to do is I'm going to pause my recording. I'm going to let you guys leave, and I'm going to finish 13. And then you can come back and listen to the last 3 minutes of the video so that we're finished with this section and you don't end up with 2 sets of homework between Tuesday and Thursday, okay? That's my plan. So what we're going to do is we're going to do a set of ordered pairs like we did before, but we've got to have our ordered pairs so that they go into the right places. So I'm going to create my number line chart, and I need values that satisfy both values that are less than 0 and greater than 0 because those are the pieces upon which this function is defined. So I need to have values both less than 0, that's negative. So maybe I pick -2 and -1. And as I pick them, I have to plug them into the top equation because those are the values for which the negative applies when x is less than 0. So if I take -2 and I plug this in, what do I have when I have -2? 2. It would be square root of 2. And so now I automatically have decided I don't like 2 and I'd rather have used 4. So I'm going to fix it. We're going to use 4. Okay, so negative of -4 would give me the square root of positive 4. And the square root of 4 is 2. How about -1? Well, -1 gives me a positive 1. Square root would be a positive 1. So I'm going to have those pieces. And while I don't get to pick 0, I can almost pick 0, because I'm going to show you what happens when I do. If I were to plug 0 into the top equation, it would in fact also equal 0, right? It would. But now I actually get to really plug 0 into the second equation, and 1 and 4. So this is square root of 0 is 0. Square root of 1 is 1. And then the square root of 4 is 2. So on my graph, I wanted 4 out here. Sorry, I'm real close. I will plot those points. -4, 2. -1, 1. I had 0, 0. And this graph is an absolute value graph, and so you know this piece of it looks like this. What actually happens here is I don't have the value 0, I have an open circle at 0. But it just so happens that I do have 0, 0 on the other graph, so I get to fill it in, and then I do 1, 1, 4, 2. And I end up with this very funny looking graph. All right, it's funny looking. What's my domain? Negative infinity to infinity. What's my range? 0 to infinity. On the far left of the graph, what is initially happening? It's decreasing. So this one is decreasing from negative infinity till 0. And then from 0 to infinity, it's increasing. There's no constants. Is it a function? It is. It's a funny function. It's defined piecewise, but it's funny. All right, so I'm going to pause, let you guys leave now. I'll record 13. I'll probably go to my office to record 13 so people can come back in. So make sure and tune in to the last 5 minutes or so of this video. Catch that part of it. It's posted in Canvas if you haven't looked at them yet. And then you'll be able to pick back up from where you left off, finish off the notes, and you'll have sections 2.1 and 2.2 completed for notes. All right? You know what I'm going to do? Actually, I'm just going to stop it. I'm going to record the last minutes as a separate video. That will be the case because otherwise it might actually lose my entire video if I walk across campus and it disconnects my internet. So there will be a second video, very short. You'll watch that.